Have you ever looked up at the night sky and wondered, what's out there? It's a question that has captivated humans for millennia. We gaze at the stars, those pinpoints of light scattered across the black canvas of space, and we can't help but feel a sense of awe and wonder. As we've learned more about the universe, we've discovered that it's far vaster and more mysterious than we ever imagined. Our planet, Earth, is just a tiny speck, orbiting an average star in a galaxy we call the Milky Way. And the Milky Way, it's just one of billions upon billions of galaxies sprinkled throughout the cosmos. This realization naturally leads us to another intriguing question. What's the biggest thing in the universe? Is there a limit to how large things can get? Join me on a journey through the cosmos as we explore the mind-boggling scale of the universe and uncover some of its most colossal inhabitants. Our exploration will take us beyond the familiar realm of stars and planets to the realm of galaxies, superclusters, and structures so vast they challenge our very understanding of the universe. Get ready to have your mind blown. Before we can even begin to comprehend the size of the largest structures in the universe, we need to wrap our minds around the sheer vastness of space itself. It's a concept that's difficult to grasp, even for seasoned astronomers. Imagine this. You're standing on Earth, looking up at the moon. It seems pretty far away, right? In fact, the moon is about 238,900 miles from Earth. That's a considerable distance, but it's practically nothing compared to the distances between stars and galaxies. To make sense of these cosmic distances, astronomers use a unit of measurement called a light year. A light year is the distance that light travels in 1 year. Light is incredibly fast, traveling at a speed of approximately 186,282 miles per second. That means that in 1 year, light can cover a distance of about 5.88 trillion miles. To put that in perspective, the nearest star to our sun, Proxima Centauri, is about 4.24 light-years away. That means the light we see from Proxima Centauri today actually left the star over 4 years ago. Thinking in terms of light-years allows us to start grappling with the immense distances involved in astronomy. When we talk about objects being millions or even billions of light-years away, we're essentially looking back in time. We're seeing these objects as they were millions or billions of years ago, when the light we're now observing first embarked on its journey through the cosmos. Let's consider our own galaxy, the Milky Way. It's a barred spiral galaxy with a diameter of about 100,000 light-years. That means it would take light 100,000 years to travel from one end of our galaxy to the other. And within this vast galactic expanse, our sun is just one of an estimated 100 billion stars. But the Milky Way is just a drop in the cosmic ocean. The observable universe, the portion of the universe we can currently observe from Earth, is estimated to be about 93 billion light-years in diameter. That means there's a mind-boggling amount of space out there, filled with countless stars, galaxies, and other celestial wonders. Section 4. Defining big in a universe of extremes. Now that we have a better sense of the sheer scale of the universe, let's talk about what we mean by big. In our everyday lives, we typically think of size in terms of length, width, and height. But when it comes to celestial objects, big can refer to a variety of factors including size, mass, and gravitational influence. Size refers to an object's physical dimensions, such as its diameter or volume. Mass, on the other hand, refers to the amount of matter an object contains, and gravitational influence is about the extent of an object's gravitational pull on its surroundings. In some cases, an object might be incredibly large in terms of size but relatively low in mass. For example, a nebula is a vast cloud of gas and dust that can span hundreds of light-years. However, nebulas are incredibly diffuse, meaning the matter within them is spread out over a huge volume. As a result, their overall mass might be relatively low. On the other hand, some objects are incredibly dense and compact, packing an enormous amount of mass into a relatively small space. Black holes are a prime example of this. These cosmic monsters are formed when massive stars collapse at the end of their lives, creating regions of space-time where gravity is so strong that nothing, not even light, can escape. Section 5. Cosmic giants, galaxy walls, and superclusters. As we venture beyond the realm of individual galaxies, we encounter structures of truly mind-boggling proportions, galaxy walls and superclusters. These cosmic giants are among the largest known structures in the universe, dwarfing even the mightiest galaxies. Galaxy walls are immense, flattened structures composed of thousands of galaxies linked together by gravity. These walls can stretch for hundreds of millions of light years, resembling colossal cosmic filaments woven into the fabric of space-time. Superclusters are even larger, consisting of dozens or even hundreds of galaxy groups and clusters, all bound together by gravity. These cosmic behemoths can span hundreds of millions or even billions of light years across. To give you an idea of the scale we're talking about, imagine shrinking our Milky Way galaxy down to the size of a dinner plate. On this scale, the local group, the cluster of galaxies that includes the Milky Way, would be about the size of a small room. But the Laniakea supercluster, the supercluster that contains the local group, would be comparable in size to the entire continent of North America.